Huge flask here today. So that's a normal size one there in the back. That's the normal size we use for this live. If you've been on the live before, look at the size of this big one we got going on here today. We've got a big one for you. A big one. Let me get the lighting right here. We want lots of light here. Okay. All right, here we go. Let's get some water going. Where's my gallon of water? Oh, there it is. How you doing there, Giga Bean? How you doing there, Kino? We got a larger container here, much larger than we usually use. I'm pouring in 1 gallon of water. Wonder if that's going to do the whole thing. No, we're going to need a little extra. See here's the, if you look back here, here's the size of the beaker or the flask that I normally use. Here, let me just stick it right there. You see that? Look how tiny it is over here. That's our normal size. This is what we're going with today. Much bigger. Much bigger. Thanks, Giga Bean. Great to see you. Looks like I'm going to need a little more than a gallon. I think that's a good spot right there, okay? A little more. There we go. Fill that baby up. Okay. Hello, Kim. Kim John. Let's get this up just a bit more. Yeah, I think that's going to look nice. Okay. Now we're going to get the stir bar going. I've noticed that I can't quite get it going really fast. No, come on, Tate. We're gonna have to block you with comments like that. There we go. See if we get the little spin going. Now this is a much larger container than I normally use. Here, back here, you see over there on the left. That's the normal size. We've got a much bigger one. You're gonna love this. I was playing around with this yesterday on a live, and just the flow patterns you see they persist longer. They're prettier. They're larger. So I'm gonna turn this up just a bit more. See if up here at the top we can get that vortex going. I'm just starting to see it form. I think you guys might not be able to see it. Maybe it's because it's not quite centered. Let's get just a bit more speed. See, if I go too fast, it knocks it out of orbit, so to speak. All right, let's see if we can get this guy going here again. Try to center it a little better. There we go. Let's see what we get. There you can see it. See it up there at the top? So what I'm gonna do is I'm gonna add, I don't know, maybe 1, 2, 3, 4, 5, 6 drops of acid up there at the top. And now I'm gonna start adding the universal indicator. This is cool. This is just cool. Let me get a fresh dropper. So I've added some hydrochloric acid, same acids found in your stomach. I've added that to this container here. And now I'm going to start adding some universal indicator. It's also known as rainbow indicator. It displays these different colors depending upon pH. All right? So here we go. In goes the universal indicator. You'll notice it's green, which means it's neutral. So universal indicator is green. Let me go ahead and add it to this. And you can see it has a red color. Of course, that's because I've added acid, and you know, if the universal indicator's in an acid, it's going to look red. But just look at the interesting flow patterns that you get. Sometimes you'll even see like it looks like it oscillates, like it goes down to the bottom where the stir bar is, and then it heads back up to the top. I don't know about you, but I just think that flow that you're seeing there is beautiful. I'm doing well, Kim Jong. How about you? Really pretty. All right. Now we'll get a little bit more going. Here we go. A little bit more. Oh, those are beautiful. Man, those are beautiful. So you see a little green at the top. I'm not seeing it. The blue thing is just a light. It's just a light that, see, if I take the lights away, it's just not as pretty. It's just not quite as pretty. So we're going to go ahead and pop these back in to give us some, nice backlighting. All right, let's go ahead and pop in some sodium hydroxide base here. And that's going to, of course, generate a blue color. We got a nice contrast going on between the red and the blue. Nice. I'm going to add quite a bit more base here. There we go. And let's add a shot of the universal indicator. It's kind of like a faint pink and a faint blue. We're going to develop a little bit more color. See, our universal indicator is green. And I'm going to add, look at that. You can tell that it's mostly acidic there in the middle. God, that's gorgeous. It's really pretty. And this is a really, really large container. Looks like the whole rainbow in there, man. That was gorgeous. That was gorgeous. Yeah. Here's the size of the container that I normally use. Right? It is really tiny. You know, this is the size of the container I normally use. It's just really small in comparison. And this is over a gallon, maybe a gallon and a half. Yeah, I'll be checking those comments, Patrick. I let a couple of them slide, but if I see more like that, I'll be banning some people for sure. There we go, a little bit of acid. It's also known as hydrochloric acid, the same acid that's found in your stomach. And we can see that there's a shift to a low pH. Here we go. We got like pH 3 and 8 or 9 in the same flask going on right now. It takes a while longer to homogenize the solution in this much larger gallon and a half container. How you doing there, Peter? Good to see you again. Thanks for hanging out with us again. We've got our large container here. Thank you there, Zach. Thank you, Patrick. Dennis Sharp, you said double tap. Do I double tap on a comment that's, inappropriate, or at least I consider inappropriate? It's my live. I get to make the rules. So if I do that, then, then I can remove comments. Look at that gorgeous little line of violet heading down. It's like a tornado. I agree, Rabbit Hole. Oh, thanks, Dennis. So, Velicity, what that blue thing is, the blue thing that you're seeing, in here I have a mixture of dyes known as universal indicator. And universal indicator displays these colors at different pH values. So, right now we're seeing some green and some blue, and that tells me that in the flask there is some material at pH 8, which is slightly basic, and also pH 7, which is neutral. So watch what happens if I add some acid. I'm going to add some acid known as hydrochloric acid. It's the same acid that's found in your stomach. So I'm going to go ahead and add that, and you see a shift to a red color. You see a shift to a red color, and that's, of course, telling us that I've added acid. Yeah, now we're going to add some base. The base I'm adding is sodium hydroxide. And it goes up here at the top. And we're seeing some really interesting flow patterns. Come on, Kino. The chemist has entered the chat. If you check out Kino's comment, Kino has indeed put the correct chemical equation for the reaction that's happening between the hydrochloric acid that I add and the sodium hydroxide that I add. And you'll notice it's making salt water. Now, if these are perfectly balanced, the amount that I've added is perfectly balanced, in those regions it'll look green. If it's not balanced, if there's an excess of acid, you'll either see yellow, orange, or red. The further it gets from 7 or the redder it gets, the more acidic it is. And then if there's an excess of base, you're going to either see like an aqua, a blue, or a violet. And of course, in this direction, the further it gets from 7, the more basic it's going to be. So this is very basic right now, right? pH 10. Let's go ahead and add some acid, see if we can neutralize this. Here we go. A couple drops of hydrochloric acid up there at the top. Again, hydrochloric acid is the same acid that you find in your stomach. And we can certainly see a shift to a red color. And we're going to find out has there been more acid added or more base? As the mixture homogenizes, I'm thinking we're going to remain quite basic. It looks like the base is overcoming the acid. So let me add just another drop of acid over here. You can still see that red in the middle. Oh, it's really pretty. Really pretty. And we're getting all kinds of colors as different regions are displaying different pH values. Looks like I've just lowered the pH to maybe a 9 or an 8, somewhere in that neighborhood. So let's add another drop of acid. We'll put it right here over here on the side. In it goes. And we can see those swirls of red. I agree, Peter. Oh man, it looks like we may have finally neutralized the base. Down here at the bottom, it's neutral, right? It's green. And up at the top, there's an excess of acid. And as the entire mixture homogenizes, we're going to find out what pH we end up at. Looks to me like it's going to be like a pH of 6. I agree, Diana. It is very pretty. Looks like a pH of 4 or 5, yeah? Maybe 6. Administrator, welcome on board. Thanks for saying hi. Hope you're having a great day. I'm going to go ahead and continue to add acid here. I'm doing okay, Administrator. How are things going with you? I hope they're going well. A little more acid. Is the main constituent of your indicator phenolphthalein? Peter, I do not know what the constituents are by mass. That I cannot tell you. What I can tell you are the 4 different, let me add a couple drops of base here. There are 4 different indicator dyes in my version of Universal Indicator. And those dyes are thymol blue, methyl red, bromothymol blue, and phenolphthalein. So in my mind, I'm guessing it's about a quarter each, but I'm sure the exact masses aren't quite that. Big boy dropping the chemical symbol. Big boy, come on, see ya. See ya, big boy. Put user in timeout for 24 hours. I agree. I agree, Crossfire. My brain likes it too. Yeah, big boy always comes in here and posts some racist shit. I don't need to see that. Nobody needs to see that. Come on, man. We're all human beings. He is definitely gone. Yeah, I don't play with that. I don't play, sorry. We're all human beings, man. Administrator, I love giving people 2nd, 3rd, 4th, 5th, 6th chances, but, you know. I agree, Tara. I definitely agree. It's definitely mesmerizing. And Big is also timed out. What is this study hour? What this is a very large container. It contains about a gallon and a half of water. It's really big. You can see like my hand is, it's pretty tiny compared to this. Probably, Administrator. Anyway, and in the water, I've added a pH indicator that displays different colors depending upon pH or how acidic or basic something is. So, yeah, thanks, Big Grizzly. Yeah, there are chemicals in there, Caden. One of the chemicals is water. Water is indeed a chemical. And there are also 4 other chemicals that change color depending upon pH. And pH is just a mathematical description, so long, administrator, mathematical description of how acidic or basic something is. Hey, good morning, Peter. Have a nice weekend, administrator. What would happen to the color if you put fluorantimonic acid in there? RbO7, I imagine it would go red. Let's go, Chris. Let's try it. All right. We're going to try to make it go green for Chris. So this is mostly acidic right now. Okay. Hey, it's WTF. I appreciate your opinion. It's my channel. I'm going to go ahead and ban people. So here we go. It's pretty acidic. And I am going to go ahead and add some base to try to make this go green. So in goes our first drop of base. We're going to try it here, Tara Chad. Thanks, Air Gas. It helps me too. We're going to add a second and third drop of base. So why is it changing colors? Study hour is changing colors because there are compounds in there that change color depending upon pH or how acidic or basic something is. So right now it's too high. The pH is too high. I added too much base. So now I'm adding some acid to neutralize the base. And hopefully, if I balance the acid and base perfectly, we'll get to pH 7, which is neutral. Right now it's quite acidic. Snake Beast, red 40 does not change color in these in this pH range. You're too kind there, Shark. Okay, let's add a few more drops of hydrochloric acid. It's the same acid that's found in your stomach. We're going to try to get this to be green. I hope I can pull it off. Thank you there, Study. What defines color? Ha! Big grizzly bear dropping the philosophical question. Or how does it make the color? It's funny there, Tara. Make sure you do your homework. There's a couple more drops of acid there. That's correct, RBO. Anything 3 and below remains red. Okay? Anything pH 10 and above remains violet. How you doing there, Terminator? We're trying to get this to be green. I'm getting close. You can see I'm at like a pH of 8. Thank you there, Shark. I appreciate the subscription. What is the indicator? So the indicator is a mixture. That's correct, Big Grizzly Bear. So if you look here, these are the different indicators that are present. So this over here represents the sum of the first 4. So this is the universal indicator, which is the sum of the first 4. Carla, I would say the advice is the advice is just do your best. Okay. What happened? We put a raw egg in a container with vinegar. It's turning green. So there we go. I got it green. So there was a question. Of, how did the colors change? Depending on how many protons, that's what happens when we add acid. Depending on how many protons are in the system, the thionyl blue is going to change color, the methyl red is going to change color, etc. And we just add these up together to get the color in universal. Can't we use pH and POH to calculate 14 and then use the volume to drop? Yeah, we can do that. Sumayat, sorry I'm not saying your name right, but we did get some green there. Can I get a little more green? I can try, Patrick. We're going to try to go just a bit more base. I'm going to just add a half a drop, I hope, up here at the top. See if we can get that to go a little darker green. You're welcome there, Chris. Right now we got like the Joker colors. We got green and violet at the same time. I'm not sure this is going to go a dark green, but we'll see. We will see. I think I shot too far. I think I went too far. So here we go. There we go. Yep, we got some Joker colors. We're trying to get a nice green. What's the thing at the bottom? It's a little magnetic stir bar. Little magnetic stir bar. And it's on a magnetic stir plate. So the stir plate has like a magnetic fan blade in it. And as it spins that little stir bar. Thanks, there, MIR. Yeah, yeah. Come on, man. So, yeah, let me just talk a little bit about the philosophy of what I'm trying to do here and why I ban people. Um, there's a lot of negativity online. I think we all know that, right? And so this is just a place where we can look at the beauty of the universe in a color changing chemical reaction. We can talk to each other respectfully and refer to each other respectfully and just enjoy each other's company and just have it be a time where we're not arguing all the time. Let's just enjoy. So LGAM, what I am doing, I like now Red Kim Jong. So what I'm doing is I have a flask of water here, and in that water I have some universal indicator, and universal indicator changes color depending upon pH, which is just how acidic or basic it is. So right now we see the indicator is violet. We see it's violet. Thank there, Frenzy. And that tells us the pH is 10. Now watch what happens when I start adding some acid to the mixture. There we go. You see some red develop. And if the acid and the base are perfectly balanced, it'll be here green at neutral. Thank you there, Carla. I try doing about once a week is what I try to do, usually on the weekend. Sandboxels, a fun chemistry game. Interesting. What type of acid? The acid I'm using is hydrochloric acid. It's also known as stomach acid, and it just happens to be the stuff I'm using is like 100 to 1,000 times more concentrated than what you find in your stomach. So RBO, the scariest chemical I have worked with, is probably piranha solution. Piranha solution is a mixture of hydrogen peroxide, which is a very good oxidizer, and snake beast, I'll get to that in a question, hydrogen peroxide and sulfuric acid. So the blue things on the side, they're just lights. They make everything look prettier. See if I take them away. It's just backlighting, man. Backlighting makes stuff look great. So that's what those are doing there. The molar concentration, Crossfire, it's not edible because one of the dyes is a laxative. The molar concentration, VKH, I don't know off the top of my head. I think it's 6 molar for both the sodium hydroxide and the hydrochloric acid. What I do know is it's 20% by weight. Hey, thank you there, Jill. Ozzy, I am using universal indicator. That's right, Tara Chad. Thank you, Carla. It depends what you define as a professional chemist. I have a PhD in chemistry from the University of Michigan. I have a master's degree in chemistry from the University of North Carolina at Greensboro. And I have been teaching chemistry at the university level for well over 20 years. Nice, Joe. Appreciate the comment. Thanos juice. I love it. Nice comment. Nice comment. Have you ever made the chemical reaction that keeps changing color like a strobe? So I think you mean like oscillating chemical reactions. Come on, VK, keep going. One semester, you're going to get your bachelor's degree. I'd love to have you a student, Carla. Thank you there, Sabash. Appreciate that. What was my PhD thesis, RBO? I worked on, there's an enzyme in green plants that catalyzes the very first chemical step of photosynthesis. And what the very first chemical step of photosynthesis is 2 water molecules go into the plant. It reacts with this enzyme, and the plant rips apart. Thank you there, Shrey. It rips apart the water molecule, and it forms a molecule of oxygen, which the plant releases as waste. It's good for us. And the protons and electrons from those water molecules are used by the plant for energy. Now, it's got to go through a process to use that to so to speak fix the electrons and protons as energy. But I was interested in how in the world do plants make oxygen from water? That's what I was interested in. Thanks there, Shrey. Thank you there, Jill. Little green plant for me. I love it. Thank you so much. So Carla asked, why did I choose the name Tommy Technetium and not tantalum or thorium or titanium? So thanks there, Tara. So I chose the name Technetium because because I love all of science, and because Technetium speaks to John Bennett. Come on, is this John Bennett? I'm not going to be in Philly. Sorry, buddy. So yeah, I chose the name Technetium because it's involved in medical science. They use it as a medical tracer, so it's in biology. It shows up. Yes, correct. I did photosystem too. I did EPR spectroscopy and also XAFs and Zane, so X-ray spectroscopy. Carla, I do a face reveal at the end. And I just talked to you guys for a bit at the end. Yep. All right. So you did BZ reaction and PChem 1. Nice, VK. That's some cool stuff. Very cool stuff. So I'm back to why I chose the name Technetium. It's obviously involved in chemistry. It's also involved in physics. It's also involved in astrophysics because... Oh, yeah, absolutely. RBO is asking me the question, was there a thesis you wish I could have done, but instead I didn't for one reason or another? Yeah, so when I went to get my PhD, I had a child, and when I started, and I had one coming. So, and then I had another kid while I was in my PhD program. And because my main priority was my family, but I still wanted to, try to get the PhD, I wanted to be home for my children. And so I didn't want to be consumed by the PhD because I just wanted to have time to be a dad, RBO. And so what I chose was a topic that I had some experience in. So I got my master's degree. I studied some photosystem 2. This is before kids. I got a master's degree studying photosystem 2. And so I had some expertise in that. And I figured, just to be expedient and to, have some experience and feel comfortable, but also be able to have some time to be able to, be with my kids, I figured, okay, I'll just study photosystem 2. Because for me, the goal was really just to get the PhD. That's what I wanted. It was just something I wanted to do in life. Thank you there, Carla. How you doing there, Gigabean? I to tell you, it's gotta be natural. Have I ever used dry ice for experiments? Absolutely, Ozzy boy. And the other one that you mentioned, absolutely, I've done that. So long, VK. Thanks for hanging out. Crimson, I got my master's degree in North Carolina. I got the University of North Carolina, Greensboro. Thanks, RBO. But if I was gonna, do what I really wanted to do, I'd have done theoretical chemistry. Peter, I got a new member on my channel. Thank you there, Peter. Appreciate that. Liquid nitrogen, Carla, is stored in a thermos. We call it a dewar. Dewar is just a fancy name for thermos. Sure, Vanita wants me to explain the experiment. So, and by the way, Peter, thanks for becoming a member. It's really pretty. What is it, like $2 to become a member? It's not much. So I, appreciate it. Anyway, so what is going on in this experiment? In this flask or this container, I have like 1.5 gallons of water. And I also have a indicator called universal indicator. Thank you there, Kim Jong. I appreciate that. And universal indicator displays different colors at different pH values. pH just tells you how acidic or basic something is. If something has a pH of 7, it's neutral. If something has a pH lower than 7, it's acidic. Higher than 7, it's basic. Thanks, Peter. You're right. It is. It's cheap. It's cheap to be a member. No, this is not potassium permanganate, Leventes. Welcome back, Slow. It is universal indicator. Oh, that's cool. Subash says they just learned that they can do rotational spectroscopy for finding the temperature of a sample. Yeah, absolutely, right? Sure enough, You know, looking at the different distributions of the lines in the rotational spectrum, certainly, you know, those are going to shift depending on temperature. Yeah, that's cool stuff. Absolutely. I thought it would be interesting to see what would happen if the backlighting position was replaced with magnets and added ferrofluid. Carla, I do not know. I don't know much about antimony. I think it is because I do know that the Egyptians, you know, back in the day, they used antimony compounds for eye makeup. Oh, wow, Ozzy. Giga Bean, I hear you, but I want to keep it natural. I think I just kind of think it's important. Vanita, I have done fluorescence experiments. You can check out my channel. Some of my videos that I've done definitely deal with fluorescence. I should probably circle back and hit those. Have I ever used antimony? I have not, Carla. Have you? I'm not using any arsenic, Subash. You're welcome, Vanita. Thank you for the question. Carla, have you ever used antimony? So Peter is saying antimony is absorbed through the skin. Yeah, lots of materials are. The issue is, Peter, is whether, you know, that absorption through the skin is going to cause harm to the human organism and how much needs to be absorbed in how short of time. And you look that up and let us know. I'd be interested to hear. So Peter is saying it does cause some health problems. So Peter, I wonder if, you know, the Egyptians did use antimony compounds in eye makeup. I wonder if that caused any issues with them. So Snake Beast is asking, what am I dropping into this container? I am dropping either hydrochloric acid, which is also known as stomach acid. And when I drop that in, the pH drops, it becomes more acidic, and it's going to shift to more red colors like what you see here at the bottom. I'm also adding sodium hydroxide, which is a base. That's this stuff. When I add in base, you're going to see the pH rise. That's basically the experiment. And we're just checking it out and looking at the beauty of the experiment. That's what we do. And we talk about science, we talk about life, and we keep it positive. Yep. So I don't mind blocking people if they're, you know, being knuckleheads. All right, here we go. Let's add a little hydrochloric acid here. You can see some really interesting flow patterns. What? Azurite. I thought azurite was a copper compound study. So Peter drops some facts there, which I appreciate. The compounds of antimony, which is what the Egyptians use in their eye makeup, those are a lot safer than the metallic form of antimony. Thank you there, Peter. So Thor asks the question, why is it purple? It turns purple if the pH increases. It turns purple if the pH increases. So Giga Bean's got some radioactive lead 214 messing with their TV. So here, I'll add some sodium hydroxide base to this. We're going to add it right here to the middle. We can watch that violet color grow in. We're also going to see some quite beautiful flow patterns. I think we can see the flow patterns a little better if I add a little more. I think that's right, Carla. Stibnite. I think that's right, Carla. So Carla dropping some facts in the chat. You know, don't be afraid to check each other. We will make sure we get the information right, but I think that's right. Stibnite is the compound probably used by the Egyptians for eye makeup. Peter's mentioning the LD50 of antimony. I imagine that's the metal, is 50 milligram per meter cubed. It's usually, I'm adding universal indicator right now. It's usually listed in terms of milligram per kilogram of body weight. Why does thorium's electron go 6D instead of 5F? Kim Jong-un. So here's the deal with electronic configurations. Holy cow. There are like 5 different things that you ultimately need to know in order to be able to accurately predict the electronic configurations of all the elements. And those 5 things, there's like several of them that involve some pretty deep theoretical chemistry. So things like, oh gosh, it's hard for me to even remember the names of the concepts you need to know in order to be able to describe this. So that's a long answer to say, I have no idea. If you really want to get into why all the elements have a certain electronic configuration, you're going to need to study some pretty deep physical chemistry for a while. So so Subash is adding what I added from the pipette. That's the universal indicator. So that's the stuff that changes color, okay? That's the stuff that changes color. I do know the periodic table, Samuel. Do you? Do you mean by memory? Is that what you're asking? Do I know the periodic table by memory? I agree, Fwenzy. It's just so beautiful to see all those different colors. Hey, buddy, Thor's asking the question, what's your favorite element? Yeah, I do, Samuel. I do know all the elements by heart, in order. My favorite element is hydrogen. It is the basis, the proton. Proton with electrons singing around it. It's the basis of the entire periodic table. Samuel, how do I know all the elements? It's because I just for most of my life I've just tried to memorize it. Hey Carla, come on, that's I love it. Oh, that's great, Carla. It does look like a nebula. I love the name of the new account, Carla. That's really sweet. Yeah, I've heard of bismuth, reusin. I sure have. It's found in Pepto-Bismol. There we go. LBD50 of antimony is 3.2 grams per kilogram. But if it's in the air, that's where it's 50 mgs per meter cube. Got it. Come on, Samuel. It's just like anything else in life. I've spent a lot of time doing chemistry, and I've loved it. And if you can put those two things together, spend a lot of time working on something and loving it, you're going to learn a whole lot. So I love Tommy says, why do gallium and bismuth make crystal shapes so easily? You've stumped me. I do not know. I do not have an answer to that question. If anybody else happens to know, you have an answer for that question, drop it in the chat. The real questions are, what is your favorite color? And why is candy corn the worst candy? So RBO, did you see my video on candy corn where we asked people what kind of candy, Halloween candy, they most wanted to see me oxidize using chemistry. Candy corn was the most suggested one, so we went ahead and oxidized that with some potassium chlorate. That was a lot of fun. So my favorite color, man, I think I like violet. But I'm going to just say this is going to sound weird, but my favorite color is rainbow. You know what I mean? Like I'd just like to see them all, Why limit it to one color? For example, this is violet right now, okay? This is violet. Right? And it's cool. I love the color violet. But what I really like, Tommy, I do not know what you're referring to. But what's really cool, here we go. I'm going to add a bunch of acid here. And when you see a variety of colors, it just is so much more beautiful than the violet alone. That's right, man. My favorite color, Ozzy boy, is rainbow. Ha, nice, Peter. How you doing there, Shark Bite? Welcome aboard. We are doing chemistry in a 1.5 gallon container. So Kim Jong would like to eat Sprite made from battery acid. Snake Beast wants some yellow. All right, we're going to try it. Yellow's a little tough, but we're going to go for it. Right now we got some homogenization that needs to happen, and it occurs very slowly. You got to know this. This is the size of the flask that I normally use. Here, we'll show it to you back here. Whoop. That's the size of the flask I normally use. It is tiny, so this thing is huge. So it's going to take some time. How many elements do I have in my collection? Well, I do have a periodic table that was given to me by a student that has at least 50 elements embedded in some plastic, but I don't know if that really counts. There we go. I got the yellow. It's just slightly greenish yellow. Let me just add just another drop, just a little drop of red. See if we can't get that to go to a yellow color. No, I don't, Kim Jong. I don't mess, man. I don't mess with dangerous stuff. Yeah, I mean, of course, all chemicals can be dangerous in certain contexts. I guess what I'm trying to say is I don't mess with chemicals that I have to be really careful using to remain safe. Like really careful. So RBO mentions that bismuth makes crystals easily because of high atomic mass and low surface energy. Interesting. Now it's Red Hulk. Samuel's got some lithium. Uranium is cool. I agree with that. Uranium, you can do some cool stuff with it for sure. And safe. Safe. And I hear you. I hear you. Oh boy, we got a lot of comments coming through. Here we go. What's my favorite scientific topic? Wow. So Peter likes some cesium. So Peter, I've never used cesium, but I have tried rubidium in water. Kim Jong, I don't think so. I don't think so. Tungsten is very cool. So RBO has made some bismuth crystals, which I would love to do. Duck walked up to a lemonade stand. So what is my favorite scientific topic? It's whichever one I'm doing at the time. I mean, I know that's a cop-out for an answer, but I really am a generalist. I love all of science. And so fortunately I have people in my family. I have like a physicist in my family. Rubidium is cool, Peter. I've dropped that in water a couple times, burnt a hole in the desk once and broke beakers both times. Yeah, I got a physicist in the family. Come on, Peter, you did some rubidium strontium dating. Did you really? Tell me some of the things you dated. So right now, my favorite scientific topic is rubidium strontium dating, because I might learn about a little bit of it from Peter. Come on, what did you date? Is the composition of that universal? No, it's known, Thor. Thank you there, Samuel. So have I tried on the channel to synthetically create gallium? Would like to learn from a trusted source. So, Ozzy, I'm not a synthetic chemist, and I'm not like a chemist that tries to extract things. So, granite rocks in South Africa. Tell me a little more, Peter. Tell me a little more about what's going on. Granite rocks in South Africa. Just give me a little bit of, the geology of what you were doing. And just a little context. I'd like to hear a little bit more about what you did. So, Thor, this is what my universal indicator is made of. It's made of 4 indicator dyes. One of them's thymol blue, one of them's methyl red, one of them's bromothymol blue, and the other one's phenolphthalein. So it's these 4. And if you just look up composition of universal indicator, Thor, I believe you will find several recipes. I know there's a recipe in the Journal of Chemical Education. So shark bite meant Helen Sharman and got her to record a message for their father for his 40th birthday. She was the first English astronaut. That's cool. That's cool. Kim Jong is asking, what are minerals? I'm not sure Yeah, the phenolphthalein is cool. I'm not sure I know the specific definition for a mineral, so I'm not gonna touch that. But if somebody wants to, do a little Googling and check yourself, give us a solid answer on what some definitions for minerals are, Kim Jong might appreciate that. Off the top of my head, I can't So you're doing isotopic age determination of Cape granites in South Africa. That's cool. What was Peter? What was the oldest age you got? Samuel, just keep doing what you love. You just keep doing what you love. So what makes a tornado at the top? So just to give you some context, Peter, why I'm so interested in rubidium strontium dating is I used to work at a 2 billion-year-old rocks. I love it. I love it. Come on, man. So I worked in a very religiously, thank you there, Sharkbite, a very religiously conservative institution for a while. 2.05 gigayears, cool. So, Peter, I used to work at a very religiously conservative organization, and a lot of the people there did not think that Earth was ancient. And it's my job as an educator to try to get people to understand why scientists think what they do. I mean, that's just what I was trying to do. So I did an enormous amount of study on isochron dating, which is, I imagine that's what you did. I imagine you did isochron dating, but I'm not sure. And I had my physical chemistry students go through the literature, just various, looking up, the strontium, rubidium ratios for what were found in a variety of different meteorites. And I had them go through like 10 different papers. So there's like 10 independent papers. Yeah. Okay, Peter. And we went through like 10 different papers, independent papers on rubidium strontium ratios in various meteorites, and we plotted them on an isochron, and you guessed what age we got. I mean, it was just we got like 4.55 billion years is what the students got. And I did have some of my students who, most of them came from very conservative backgrounds. I had some of them tell me that exercise is kind of what convinced them that the Earth was ancient. Levente, this is not cabbage solution, but it's a great guess. This is universal indicator. So, Jay, what I'm doing is I have some water that's on a stir plate. And down here at the bottom, there's a magnetic stir bar. And as it spins, it just spins the mixture. And there's some universal indicator in here. It's just a pH indicator. It displays different colors depending upon pH. And these are the colors that it displays. Like right down here at the bottom, it looks violet. So down at the bottom, the pH is 10, which is very basic. Up here at the top, it's a little more green, maybe bluish. So up here at the top, maybe we're neutral or just slightly basic. And here, check out what happens when I add some acid. You did a meteorite at 7 billion years? That's confusing to me, Peter. 7 billion. Because I thought our solar system was 4.5 billion. And so how did you get a meteorite at 7 billion? That must have come from somewhere else. That would be a rare meteorite indeed, I would imagine. So I love Tommy. I buy my chemicals. Most of them I just get at the store. Samuel has asked an interesting question. I think it's kind of philosophical in my opinion. The question is, what's the most dangerous element? In my opinion, it's thallium. Thallium has been used in rat poison in the past. It's very difficult to detect thallium poisoning. And so it's, thallium compounds are nasty. So the acid I'm using, RKG, is hydrochloric acid, the same acid that's found in your stomach. Kim Jong is guessing that arsenic is the most dangerous element. I don't know much about the toxicology of the elements, but certainly arsenic is one that I'm not going to mess with. I want to make sure I understand the risks of what I'm using. Well, plutonium could be another, example, the radioactive elements. So, Ozzy, you're not sure what I said when extract for gallium. So here's the deal. If I'm, what does synthetic mean? So if I have a compound of gallium and I extract the pure element gallium from, say, a gallium oxide or a gallium sulfide or a compound of gallium, it could be said that we synthesize, we make compounds from different stuff. That's just a phrase that we chemists use, that if you're going to, start with different materials and make something else, that's known as synthetic chemistry. And while I think you're technically correct, I probably misused the term synthesize gallium. I use that synonymously with extract. It's probably not correct, so I appreciate the correction. All right, Samuel. RBO, that's a great question. I don't have an answer for you. RKG is saying mercury and fluoride. All those can be scary. Study hour, I don't know, and I don't want to find out. HF is definitely nasty stuff. Aha, 2.02 billion years old. Cool. How many chemicals do I have down here? Well, see, here's the deal. I love Tommy. You gotta forgive me, but I see, for example, water as a chemical. So I don't really know how to answer that question because, any material that I see is a chemical. Cool, Gigabean. Yep, plutonium. Any element used to create nuclear weapons could definitely be considered one of the, dangerous. How does a solution detect pH? Okay, so what's the thing? I'm going to get to that, Merrick. I just want to kind of catch up on the comments here. Demon Core was nasty for sure. All right, Snake Beast, we're going to get to that in a second. Thank you there, Band. So Morgan's in the lab? Everything in the world is a chemical, says Peter. Oh, but wait, Peter, think about this for a second. Photons are not chemicals, right? Sure, study hour, water's a chemical, right? Of course it's a chemical. It's made of, it's made of atoms. I love Tommy. I buy my chemicals often at the hardware store, the grocery store. Could I put 1 drop of acid and atom in at the same time? Okay, so here we go. So let me get this to like a yellow color first. Somebody asked to put an acid and base in at the same time. We're going to do that. And I also need to answer how these things change color. How does it manage to polarize the light? Okay, Mark, will do. So this is not polarizing the light. I'm going to give you a chemical description, Mark, and after I give you the chemical description, you let me know if you're satisfied with the answer, okay? So there happens to be 4 different dyes in here, and all of those dyes... So I love Tommy. I buy my chemicals at the hardware or grocery stores. I just know what I'm doing, though. So sorry, Peter. I think about these things all the time. So, Mark, there are 4 different chemicals in here, all right? And we're just going to talk about one of them. The one we're going to talk about is phenolphthalein. So phenolphthalein, you see here, it's colorless at all these low pHs. Yep, all these low pHs, and then it's pink at these high pHs, okay? Okay, so phenolphthalein, when there's a lot of acid around, I'm going to put a bunch of acid in here. Phenolphthalein acids donate these H plus ions, which is going to be represented by this goofy little cap that I have here with an H plus on it. And there's phenolphthalein molecules in here, which I'm going to represent by my hand. And how you doing, Adiant? And when phenolphthalein sees a proton, it grabs onto it, and it makes a ring shape, just like what you see here with my hand, okay? Okay? So, when phenolphthalein grabs onto a proton and it has a ring-shaped structure, it's colorless. So, when there's lots of protons around in an acid, low pH, lots of these around, phenolphthalein can easily grab one, ring-shaped, and it's colorless. Okay, now, if bases come around, what bases do is they steal these protons. Bases are proton acceptors. So there's a lot of base around. There's going to be things that are going to pull the proton off of the phenolphthalein. And when that happens, the phenolphthalein molecule goes doink like that. It pops open. And when that structure is changed, it goes to pink. So phenolphthalein in the presence of an acid is colorless. phenolphthalein and a bunch of base is going to be pink in color. All right, so here we go. Somebody asked for me to put a drop of acid and base in at the same time. I'm going to be adding acid over here on the left. We're going to add base over here on the right. And because this is a very large flask, we're going to do like 2 drops of each, okay? So drop of acid, drop of base, drop of acid, drop of base, and let's see what happens. It looks like a sunset. It's beautiful. It's gorgeous. Absolutely beautiful. What a great suggestion. That was really pretty. Down here at the bottom, you can see they've neutralized each other, right? Because green is neutral. Let's do that again, man. That looked like a sunset. Let's try that again. Here we go. Drop of acid, drop of base, drop of acid, drop of base. We're going to do 3 this time. Drop of acid, drop of base. And let's watch what happens. How you doing there, Fwenzy? Very pretty. Thank you there, Oshkot. Thanks for hanging out. I love having you on board. Unionized indicators have a different color to when ionized, so the donation of protons changes the ionization. You got it there, Peter. That's another way to look at it. Sure enough. Do I know H.C. Verma? Adiant, I apologize. I don't understand the question. Kim Jong, that's going to depend on how much acid or base is dissolved in the fluid, more than whether it's acid or base. Thanks, Mark. Thanks. Oh, that's a very nice comment. I appreciate it. It does look magical, RK. Oh, that's funny. That is funny. I'm going to try to get this back to a yellow color. And then we're going to do that again where we get the acid and base going in at the same time. What happens when you try to imitate the pH indicator? Oh, intimidate. Thank you there, Sabash. I appreciate that. I don't know. Thanks there, TMX. I appreciate that. So Adiant saying the toughest exam in India is the JEE. Tell us a little more, Adiant. What do you tell me a little more about that exam? So what would happen, Snake Beast, if someone drank this? They'd probably leave the stream in about 10 minutes because one of the dyes is a laxative. Morgan Le Fay is now saying they are definitely an alchemist. Yeah, Samuel, I'm sorry I'm ignoring your question, but, it's not a good idea to give out personal information, right? So I do work in higher education. Absolutely. I'm a teacher in higher ed. Thanks there, Mark. Okay, we've got some yellow color here. Got it. Admissions for engineering college. Here we go. Let's add over here on the left. We're going to add some. You know what I'm going to do this time? This time I'm going to add base right in the middle of the vortex. And then I'm going to add an equal amount of acid outside the vortex. So let's do the base first. We're going to do 5 drops. 1, 2, 3, 4, 5. And then 5 drops of acid on the outside. 1, 2, 3, 4, 5. Let's see what goes on there, buds. No, don't sweat it. It's fine, Samuel. It's fine. Aussie boys saying they drink phenolphthalein daily. Wow. Acceptance rate of 1%. I'm getting hungry. It's getting close to dinner time for me. Yeah, that effect, we didn't kind of see the sort of the sunset effect with this. But Peter loves it. Peter thinks it's beautiful. I love it. I'll just leave it alone, man. I will leave it alone. It is kind of nice to see that red stream in the middle. Get a lot of interesting flow patterns for sure. Thanks for all the likes I'm seeing over there and the hearts and the congratulations. The shape of the vortex can be applied, so it's many uses. Yes, Fwenzy. Can I try the opposite? Acid on the center, base on the other? You got it. You're right, RBO. All right, so let me get this back to yellow. Let's get this back to yellow. All right, we'll get this back to yellow. And we're going to do it reverse this time. So this time we're going to do acid in the center, base on the outside. Thank you there, Samuel. I appreciate the subscription. Agreed, Mark. I definitely agree. Oh, hey, we just hit an hour. We've just hit an hour. West Coast all day. Amir asks, what's my idea about Iran? I think people in Iran are like people everywhere else. We're all human beings, and we all are just trying to make it in this life. Yellow from methyl orange, bromothiamyl blue, and thymol blue asks Levente. So here we go, Levente. These are the dyes that are present. We're using thymol blue, we're using methyl red, we're using bromothiamyl blue, and we're using phenolphthalein. And added together, they get our universal indicator. All right, so here we go. Good luck. I don't wish you luck, though. I don't believe in it, Ashkot. I wish you lots of motivation and a clear mind. That's what I wish people before exams. I'm trying to get this to yellow here. How often do I do these? Hey, thanks, Mark. I do them about once a week. It's usually on the weekend. So either Friday, Saturday, Sunday. This weekend, I've actually done it twice. So this is my second stream. I did it yesterday as well. I don't have any bismuth, Samuel. Ozzy boy, I have not tried heating it. It is like a tie-dye shirt. I'm liking this. I like it when I can sort of see the structure in the flow patterns. That's what I really enjoy. Okay, I think I've got this set. So we got to wait for the red in the middle to kind of dissipate. And when that dissipates, Peter Griffin, I get that a lot. Kim Jong, what happens if I add sulfuric acid? There's not a whole lot difference between that and the hydrochloric. So the suggestion was that I need to add acid to the middle and base on the outside. What would it taste like? It would taste like an afternoon on the toilet there, study hour, because one of the dyes is a laxative. Here we go. We're going to add 6 drops of acid in the middle. 1, 2, 3, 4. Let's do 5, and then I'm going to add 5 drops of base on the outside. 1, 2, 3, 4, 5. Let's see what happens. The glass is from a retail store. Thanks for the question, Samuel. How to learn the colors of indicators. Ashkot. I'm not sure I can answer that question. Can I increase the viscosity of the water? Not a whole lot. You can cool it. You can certainly cool it. Hey, thanks, Morgan. That's really nice of you. I appreciate that. Hope to see you around. Yeah, I agree, Subhash. So study hour, you're saying you'd drink this if you could, huh? Cool it to 4 degrees. Yeah, get it pretty viscous. Viscous, we're going to see it. Hey, I'm going to flip the camera here pretty soon. I need to start making some dinner. I'm starting to get hungry. So we'll be flipping the camera. I'll be talking to y'all. That's what I do at the end of the live. Just letting you know you're going to see a 56-year-old man. That's not something you want to see. A 56-year-old man in their basement. Then it's time to get the heck out of the live. That's for sure. But that's where we're heading. What do I think would happen if I heated it to 90? I don't know. Kim Jong says it's like drinking the essence of the universe. I don't know what thermoglass is, Ozzy. I apologize, so I can't answer the question. Nice, Peter. Thanks there, Subhash. Nice comment. Very, very nice comment. So, RBO asked, would using hydrogen peroxide instead of water change this color? We've tried adding hydrogen peroxide. It does not seem to oxidize the dyes. Well, fancy, as the reaction proceeds, this does become salty water because the chemical reaction produces... Sorry, I got a timeout. See you, Troy Smith. So we, Samuel, I pretty much do this, but there are times I try something different. So this is the basis of what we tend to do. Talk, we do some, we just, look at the beauty of this and talk, and I do try some different experiments from time to time. So RBO, I was answering your question. We have tried putting peroxide in. I haven't seen much of a difference. Yeah, I don't know, Kim Jong. I don't know if it's a bot or what it is, but, you know. So, Samuel, I'll probably be going next Friday, Saturday, or Sunday. So, RBO, if you want to see some experiments with D2O, I encourage you to look at my YouTube shorts. Yeah, I agree, Peter. I have some YouTube shorts where I do experiments with D2O, and you can see differences between the D2O and the regular water. Yes, I am using an indicator, Devidath. Sorry if I'm not saying names correctly. So RKKG is saying maybe I should, I'm guessing you're saying maybe I should use gelatin to increase the viscosity. Oh, no, it's not thermoglass, Ozzy. So, Hulks, we're going to try it. We're going to try it, but the unfortunate thing is that this flask is really big. It's like 1.5 gallons. And because of that, it has a very thick, like it's about that thick. The bottom of glass is very thick. So there's a very large distance between the stir plate and the stir bar. And that means there's a weak magnetic attraction between the two. But I'll try, okay? So you look down here. I'm going to start turning up the stir speed. Thank you, RBO. What's the coolest scientific thing I have? My brain. Come on, Samuel. It's the coolest scientific thing we all have because we all can think scientifically. That's usually what happens there, Hulk Smash. See how it's fallen out of orbit, so to speak? And we'll get it back in. Okay, I'm going to flip the camera here. It's time to end the stream. I'll be talking to you face to face. Oh, it is cool, Maya. Let's turn this around. How you like the shirt? I got the science shirt on for y'all. Thought I'd wear that today. Thanks, RKG. What do you think? I thought I'd grow a little goatee, huh? Thanks, Flenzy. Got those reading glasses on so I can see the comments. Huh. Thanks there, Study. I'll take that as a positive. Thanks there, Samuel. Thanks there, Fancy. I'm every bit of 56, Hulk. Thanks, RKG. Yeah, Kim Jong, I'd do that in a heartbeat. Thank you there, Oscar. I'd do that in a heartbeat, but, you know, actually I have. I mean, I have a former student who does YouTube channel. He runs a channel called The Science Classroom, and we've done some collabs together. I got it off, Ozzy, but I thank you for the reminder. Thanks for your study hour. So long, Mark. Yeah, I can get this light off, too. Got the electricity here. What the... There it is. Yeah, we had a good time. We had a good time today, for sure. Thanks for joining in, everybody. I had a blast. I had a blast. I always do. Well, we'll leave that on. Low lighting is better. Thanks. Thanks for joining in the magic, Sam. Hello, Frank. Frank the bot. Welcome. So long, Samuel. Till we meet again, Subash. I agree, Kim. I have a good time with y'all, and I appreciate you joining in. It's a good time. Thank you. All right, RBO. All right, Peter, I look forward to it. I look forward to it. Not sure what you mean, Frank. Hey, thanks there, Ozzy. Well, here, let's, I'm going to close out here like I normally do. Hey, Blender, thanks for dropping by. I apologize, but I'm getting ready to end the stream. Let's show you what we normally do. We just do science experiments. Yeah? We just do some science experiments. So I'm getting ready to end, but so long, Devidef. You know, here at the end, I talk to folks. All right, Peter, so long. Gonna drop a little, oh, that's a cool little drop going down there. Let's drop another one. So yeah, folks, you know, I encourage you to spend some time every day. So long, study hour. Thanks, Peter. I encourage you every day to take a little time, breathe in that fresh air, pay attention to the beauty that surrounds you, whether it's the clouds, whether it's a rainbow, whether it's the pitter-patter of rain or the snow that might be falling out of the sky, maybe a rushing brook, or just, you know, petting the fur of your favorite animal, your cat or your dog. The beauty of science is all around you, man, and this universe is absolutely wonderful. So I hope you get to take some time and see some really cool stuff, and I thank you for seeing some of the beauty of the universe here with me in this wonderful flask of colors. All right, folks, we're going to see you next time. Thanks for hanging out. And if I don't see you tomorrow, I'll see you next weekend. So long, folks.